Welcome, everyone. I'd like to just very briefly introduce Chris Hartnady. Chris is a preeminent geologist. He's very much a Cape Townian. He studied at UCT. He started off, and I'm summarizing here, on the Precambrian Research Unit, and looking at our old rocks in Southern Africa. He also has a very close association with Hermanus. Chris and his wife Rowena, and in particularly the company in Voto, have been key to unlocking and developing the big aquifers that sit below gorgeous Table Mountain sandstones, the Table Mountain group behind Hermanus. And as I think people who live in Hermanus will know, about 30% of our water supply actually comes from the aquifer at the base of these mountains. So he has a direct interest in Hermanus too, and they've really done some world-class work in that respect. Chris has diverse interests. He started looking at old Archean rocks and the development of the continents. He's also been involved in the earthquake studies, seismic studies in and around the Cape. He has great knowledge of the Tulbach and Milnerton earthquakes and how they came about. More recently, he's ventured or sort of moved into plate tectonics, and he'll talk a bit about that today, how the different plates work and how that drives volcanism, which is in a sense what he's talking about. And so we look forward to hearing Chris this morning talk about a trip that he had in, what was it, 2019 to Mount Etna and the volcanoes of southern Italy. So without further ado, I'd like to hand over to Chris and say thanks to him for making time to give this presentation this morning. Thanks, Chris.
I'm going to be talking about the volcanoes on the Nubia-Eurasia plate boundary in and around Sicily. The subtitle of my talk is From Stromboli to Etna. And this was a trip we did in May 2019. Just the background to this trip. I'd been interested in the Nubia-Eurasia plate boundary for some time, mainly arising out of work that I'd been doing on the East African rift system, but also going back to in the early 90s. In the early 90s, I got involved with NASA in their space geodesy program, and they began to do work on the radio telescopes on the African continent. Well, that's Hartnady, but there is a radio telescope on Sicily. It's at a place called Noto. And so that was the beginning of my interest there. And the mapping the motions of the plates using conventional means, magnetic anomalies in the ocean basin, or in using GPS, the interferometric synthetic aperture radar methods from space satellites, and also the radio telescope methods. So that was my interest, and my interest really went from South Africa up around the East African rift system, and then on to the Eurasia-Nubia plate boundary. So here, and then the particular spur for the 2019 trip was a rather large eruption of Etna on Christmas Eve. And so what you see is a view from an aircraft taken flying over Palermo. That's the north coast of Sicily that you see, looking towards the Aeolian Islands out in the east. And there you see the plume coming out shortly after Etna had exploded on Christmas Eve 2018. That then spurred myself and Steve Richardson, who's attending this talk, to sign up for a 9-day tour involving a trip to Stromboli, some of the other islands near Stromboli, and Etna. So that's the background. So just to put the geography here, I'll try and wave my cursor around a bit if I can get it visible. So Etna is on the east side of Sicily, looking into the Ionian Sea. Stromboli is on the south edge of the Tyrrhenian Sea. And what you see is the map of the Eurasian plate boundary, or at least one version of that boundary. That's the gray barbed line that runs round, curves around in the Ionian Sea and then runs through Sicily towards the Maghrebian orogenic belt in North Africa. In this area, the two plates, that is the Eurasian plate to the north and the Nubian, that's a part of the African plate you will see, that they converge at about 9 millimeters a year, which is a pretty slow motion in roughly a northwest to southeast direction. That is, Africa relative to Eurasia is moving northwestwards. Sorry. So, and then this next dimension, looking down, what you see in the upper right-hand corner is the Eurasian plate on the left, Sicily, and the oceanic crust of the Eastern Mediterranean being subducted below Sicily, with what is described as a slab window over here beneath Etna. Now, things are a little bit more complicated than that rather two-dimensional picture. And again, I come back to something I mentioned in the beginning. Right up in the north there, you see a black triangle marked NOT1. That is a GPS site now. There is the radio telescope, which is also a space geodetic beacon or benchmark, if you like. But there's been a fairly long-lived GPS site on Sicily. And my colleague Richard Wonnacott and I, and Richard, of course, is the father of the TrigNet system in South Africa. So we've been looking at using GPS to determine the rigidity of the Nubia plate. A plate is rigid if it is what we call the longitudinal strain rate is less than 1, or somewhere between 1 and 3 nanostrains a year. And what you see in this map is a whole number of baselines between important GPS sites, Sutherland, a Lusaka site called Zamb, and so on, and then also Noto. And what you see is that everywhere the longitudinal strain is less than 1 nanostrain a year. Just to give you an idea of what that means, 1 nanostrain per year is a deformation of 1 millimeter over 1,000 kilometers. So we are looking at the moment, we've got very sensitive techniques to measure the real-time motion of plates and their internal deformation. So that's my interest in extending from the East African rift system, where they are rather, and along the Red Sea, the Nubian-Arabian plate boundary, around into the rather more complex Eurasian boundary, which you see along the north edge of that map. So coming to Noto and southern Sicily, the important point I want to make on this slide is that area of Sicily, we call it the Hyblaean Plateau. So that's the area east of the city of Syracuse. We have the map there. And Noto is down on the further south. It's southwest of Syracuse, and that's a sort of a little close-up of the radio telescope. I visited Sicily with my wife in May 2017 to look to make a sort of pilgrimage to Noto. We didn't get to the radio telescope, but we did get to the cathedral and its fairly magnificent internal art. But as I say, the important thing about the Hyblaean Plateau is that geologically, it is a piece of Africa. So again, going back to reconstructing a sort of sequence of maps as to how Sicily developed from Pangaea, you see a sequence of fairly recently published maps over here. The upper left-hand one, 240 million years ago. And here you see Africa in yellowish colors, the Iberian Peninsula in orange, and Europe in greens. And then this area south of Europe is an extension of Africa, which is now called Greater Adria. So it is really a part of the African continent that then sometime around before 170 million years ago, that's the diagram in the lower left, rifted away from the main African continent in part, but then that rifting ceased. When one comes further forward in time, what you see in the lower right diagram is this Greater Adria continent starting to collide with parts of Eastern Europe and the Balkan region. So now the Himalayan plateau is marked HP. It's in that sort of darker yellow area. The area of northern Sicily, however, is part of what we call the Peloritani Calabria terrain, or Pica on this map. And Pica was essentially part of southern Europe in the beginning. So coming forward in time, again, about 30 million years ago, this was the position. The African Eurasian plate boundary had started to become indented by Adria driving in, or Greater Adria driving in towards the Alps. The curvature of the Western Alps is now starting to show up. The Peloritani Calabria terrain is still attached to southern France, but then about 50, or sometime before 15 million years ago, that both Sardinia and Corsica and the Pica terrain started to rift away from southern France to open the Gulf of Lion. So that's the position 15 million years ago. And then the present time, the Pica terrain has collided with the Himalayan plateau. All along the way, it's collected these other fragments of that darker yellow region, piled them up into a rather complex orogenic zone between the collided exotic terrain and the essentially the foreland of the African continent in the Himalayan plateau. So that's what we've got there. But there's also something rather more interesting about that area, in that and this is a series of maps describing from about 6 million years ago, that's in the upper right, through 5.2 million years, 4 million years, and present day, the collision of that, the Pica terrain, which is the shaded area in a sort of purplish tone, and the margin of Sicily and southern Italy, or Calabria. Now, the key thing about this is that this island arc that's coming in with the volcanoes of Stromboli and the other volcanoes of the Aeolian Islands, which are north of the Pica terrain, those are conventional island arc type volcanic units. Etna, on the other hand, has developed along and above this rather interesting structure, which the formal name for it is a subduction transform edge propagator fault, or so-called step fault. And essentially it's a big tear structure. If you imagine tearing a piece of paper, essentially the oceanic lithosphere of the Eastern Mediterranean, which is shown in the lower left there, is being torn away from the continental crust of Africa along that structure. So that's the picture. And Etna, if I just go back to that slide, sorry, Etna is directly above a kind of slab window, a gap in the lithosphere where that tear is propagating through the northern part of the island. And that's what makes it quite interesting. And studying the local deformations using GPS on Sicily has been an interest of mine in recent years. So going on to the next slide then. This is the picture then of, it's a more recent map of Etna, which is up over here. That's the summit regions of Etna over here. This is the coastline of Sicily. And the key thing about this, apart from the convergence between Eurasia in the northern side and Africa or Nubia on the southern side, is the fact that Etna itself is deforming in quite a complicated way, and in a way quite alarmingly. One of the big features of Etna is that the whole of its eastern side is bounded by faults in the north. You can see over there is something called the Pernambuco fault, and then down in the south there's something running offshore, is something called the Catania Canyon, and there's a set of faults which come in past a suburb called Mascalluccia. Those are the southern faults of a big, essentially a flank collapse of Etna. So you can see that Etna has not only got earthquake hazards because of its plate boundary and the different subduction and transform faults that surround it. There's the volcanic hazard of Etna itself, but then there's also, with the earthquakes and with the potential flank collapse of Etna on its eastern side, there's a big tsunami hazard as well. So, so those are the background of my interest, or the geological interest in this area. So the key thing, now this is going on to the travelogue now. Our trip really, we flew in, Steve Richardson and his wife Marion Ellis had arrived, I think, the day before, and they had gone northwards to Taormina for a while to be tourists there. Rowena and I arrived in on the 2nd of May, and then we went to a place called Pozzillo. I'll go back to that previous slide. That's marked on the coast there in yellow. That's a small town or village in which on the eastern side of Etna, so that's the view that we had on the morning of May the 3rd, the dawn on Etna from the bedroom of the cottage that we then were staying in. It actually belongs to a cousin of Marion's called Simona. So Simona's cottage was our base for the first day or two. We had, Rowena and I had this magnificent view of Etna in the morning, sun rising on it, and then a couple of telescopic views of Etna, further out one on the upper right. But the key thing over here is what you see that I'm pointing at now is what is called the new southeast crater of Etna. All of this is the Etna summit area. That's the northeast or north crater of Etna with the fumaroles and the steam rising. You can also see some fumarole activity here. You will also notice that there's a little bit of a white trace over there. That is the a fumarole area, which actually feeds and was the site of the rift that fed the lava flows that followed the December 2018 eruption. So you can see there are kind of a grooved area coming down below that little white area. That is the 2018, one of the 2018 lava flows in that area. Another one you can see coming down over here, these sort of channeled structures are the lavas that followed the big explosion in December 2018. So we were based at Pozzillo on May the 4th, which was just prior to the start of our field excursion with the volcano discovery team. We visited a friend of Simona's at the National Institute for Geophysics and Volcanology. They have their headquarters in a rather grand building. That's you can see that in the that's their entrance sign in this rather big mansion in Catania. And there we were received by Dr. Ornella Coccina, who's a volcano seismologist. So you see in the lower left, Steve and I in one of the areas of INGV with the map, the geological map of Etna behind us. And here you see us in the sort of a kind of museum area where Ornella is showing us some of the exhibits that they have as part of their educational materials in part of the INGV. We were also taken to the operations room, or the sala operativa, which is on one of the, or the uppermost floor, just below the roof area of INGV. And this is where they have 24-hour monitoring. As I say, because Catania is from a volcanic and an earthquake and a tsunami point of view, in a rather hazardous state. The government of Italy has invested quite a lot of money into continuous monitoring of earthquake activity, the volcanoes, so they have webcams trained 24 hours a day, 365 days a year on both Etna and Stromboli. And then all of this is continuously monitored by shifts of scientists who come in, two at a time, to make sure that if anything happens, they know about it immediately. So we were shown over that. And then our real trip with the Volcano Discovery Group began on the evening of May the 4th. We met our guide at the hotel, and he then took us down through Catania. We took a walk through the town to the Norman castle, which was affected by the 1669 eruption. So if you look at that upper right-hand map, the red areas there show the 1669 flows coming south from a fairly low elevation on the south flank of Etna. And at that time, 1669, this castle, the Castello Ursino, was right on the coastline. And it got completely surrounded by the lava flow. And about a few meters, you can see that the channel over here. This is the western side on the lower left. They've excavated down to the original foundation and the original level that the castle was originally built at. Everything else, of course, is built at a much higher level. The road level here is, of course, the surface of the 1669 flow. On the north side of the castle, they are still busy with the excavations. The idea is to, and it's part of an archaeological investigation of the castle site in that area. So that was our meeting with the two other members of our party who I'll introduce later, and our guide. So our guide over here in the right-hand image with the blue jersey is Marco Fulle. Now Marco is by profession not a geologist. He's actually an astrophysicist who works for the European Space Agency on the Rosetta mission to comets. And he's actually a specialist in remote imaging of comets in space. But his big hobby is volcano photography. And he's built up quite a reputation as a publisher, or he's published his books on particularly Stromboli and Etna have been published. And so he was our guide, and an excellent one at that. So on the lower left here, you see Marco and one of our other party members, Ros Moran from Australia, are in a cavern below the restaurant. This, what you can see with the lights on in the background, is actually a flowing stream. Now, with the 1669 flows, once the flows had hit the ocean and then continued to flow in lava tubes out to sea, the lava tubes later on became the main ways in which water gets from Mount Etna down to the ocean. So there are no surface streams in Catania. There are only these lava tubes below the lava, the rough lava terrain. So, and this restaurant has a little staircase going down to the tunnel. So that's just an interesting feature of that, our first day. The next day was heading from the hotel very early in the morning to a port called Milazzo. It's a ferry port on the north coast of Sicily, and it lies immediately south of the Aeolian Islands. The three islands that we actually visited were Vulcano, Lipari, which are closer to Milazzo, and then of course up in the eastern side, the northeastern side, Stromboli, marked with the S there. These other two islands off to the west are Alicudi and Filicudi, and then the island to the north of Lipari is Salinas, and you'll see a bit of that later on. So that was our departure. As it happened, our wives, Rowena and Marion, were leaving on the same ferry because Simona, Marion's cousin, had another house on Salinas, Salina over there. And so they were on their way to Salina while we were on our way to Vulcano. So that afternoon was the afternoon dedicated to climbing Vulcano. So this is the island of Vulcano. The port, you can see down, you can just see the harbor wall just along at the edge of the bay. This is the peninsula called Vulcanello. And then on the northern side of the isthmus between Vulcanello and the main island, that was where our hotel was. There's a black sand beach, which you will see later on. And there's an area over here on the northern side of Vulcanello, where there's something called the Valley of Monsters, with very unusual geological shapes, lava blocks that look like various bears and other kinds of animals. So this is just a view. Again, the Lipari is the island immediately to the north, and then the double-peaked island is Salina over there. And again, this is the part of the volcanic topography of Vulcanello. We were climbing up the cone of the active crater, and you'll see on the upper right some of the big lava bombs. Now there's a style of eruption called vulcanian, in which very large lava bombs are ejected with great explosive force. So, and that's vulcanian style of eruption comes from the island of Vulcano. And these were initially molten blocks, which were propelled, no doubt, thousands of meters into the air and then fell back around the volcano. So that's the view. What you also have, of course, are the solfatara, the fumaroles, and the sulfur exhalations. This is on the edge. It's on the sort of eastern or northeastern side of the crater, and here's our party tiptoeing across the and trying to stay out of breathing in too much sulfur dioxide. The actual crater pit is shown in that view in the upper right. Again, this is looking down across that solfatara area, the yellow area on the crater edge over there, with the main pit down over here below. That whole structure was created with the big eruption in 1889. The island has been dormant since. And again, you see from this view, taken higher up on the mountain, the island of Lipari and then Salina in the background. The other view out across towards the east now is the view between out to Stromboli. So that on the horizon there is Stromboli, and the island between Lipari and Stromboli is Panaria. That's the small island between the two other volcanic massifs that you see there. We were supposed to have left for Stromboli on May the 6th. That's the Monday. But we couldn't because all the ferries had been shut down by extremely bad weather. In fact, when we were, when I took this photograph, it was quite difficult to stand up because the wind was so high at the time on that ridge. And then the rain came in overnight, the ferries got shut down, and so As my title says, it was a stormy day and we had an extended stay because, well, most of the morning we had to spend in the hotel. The weather was too furiously bad. But we did manage to drive around the island in the afternoon. And so the slide on the upper right is taken mainly from the south side of Vulcano, looking up at the crater that we climbed the previous day. So, and this is another view. This is the black sand beach just on the edge of our hotel, essentially with the Vulcanello Peninsula in the background there, between Lipari and the bay. And then up in the upper right here are these. There's one of the monsters of the Valley of the Monsters that I spoke about earlier. So it wasn't sure that the ferries would be operative the next day because the weather was still fairly bad. But what we did was we made sure we left our hotel very early in the morning. And we were the first on the Vulcano harbor to make sure that if the ferries were running, we would be first in the queue, which we were. And so what you see is the harbor of Vulcano up on the left-hand side of the slopes of the volcano itself. And then in the upper right, I put in a painting which was made of the 1889 explosion. In fact, there was a Scotsman whose name I've forgotten who lived on the island at the time, and there were some artists there, and they recorded the scene of the Vulcanian eruption in that year. So we then moved to Stromboli, and this is a map of the area. We stayed in a hotel on the eastern side of the main village, which is on the northeast side of the island. And we had 2 days there, essentially. The first day, the path that we followed is in white. We were essentially doing a sort of reconnaissance hike around the northern side of the volcano towards the ridge. And then the plan was, after having done that afternoon hike, we would have dinner at a pizza restaurant called the Osservatorio down there. And that would give us a good view up the ridge that we were going to climb in the next afternoon. We had an off morning because the ridge climb would only start at about 4 p.m. on the 8th of May. And you'll see why the reason for that. So our first day was walking from the hotel through the village, past the cathedral, San Vincenzo, and then up towards the volcano, up a path. The main tourist route up the volcano goes up this ridge on the northeastern side, directly from the town. And then there's a zigzag area up here, which joins the path that we followed around about there, high up on the north ridge. So on the next day, we ascended on the north ridge, met a lot of the tourists. We fortunately, again, were up there early before most of the tourists came up from the village to settle down to look at the eruptive activity on the summit crater around about here. There afterwards, after we'd seen that, we descended at night down the scree slope over here and then rejoined the tourist path back down to the village. So just to give you an idea, that's our hotel looking up towards the mountain on the upper right. This is the view up towards the main tourist climb up to the summit of Stromboli. And then we took the contour path looking down on the town, the harbor there and the harbor wall. And out here, there's an island with a lighthouse on it. That's the island of Strombolicchio. On the upper right, you see the tower of the San Vincenzo Cathedral. This is looking up towards the summit of Stromboli from the lower part of the North Ridge. Sorry, and what you see there is the continuous fumarole activity from the summit region. There was quite a strong easterly wind blowing that day. And then every now and then you get these Strombolian explosions, these explosions and the ejection of ash into the atmosphere. And that's what you see, the brown cloud over there. On that slope below the summit area, there's what is called the fire stream, or the Sciara del Fuoco. So that's the big volcanic scree slope that runs down to the sea and is the path of pyroclastic flows or lava flows sometimes down into the ocean from that summit. So this again is our view from the restaurant looking up the North Ridge towards the Stromboli summit. And this introduces our party. The other couple on the trip with Steve and myself were Vince Morand. He was a lecturer at La Trobe University in Melbourne, Australia, and his wife Roz, who's a biologist, environmentalist. So that constituted our party. 5 of us with our guide Marco Fulle on the right-hand side of the image. And this is a view of one of these Strombolian explosions, the dark ash going out of the summit from that site. Our dinner went on into the evening, and so we then strolled back to the hotel along a coastal path from the Osservatorio. And then the next day, as I say, the meeting place was set for 4 p.m. We had a morning off just to be tourists in the town, but we then met our guide in the late afternoon. Our guide is Renzo. You can't go above a certain level on Etna without an accredited guide, who is not only your guide, but also the safety officer for your tour, and has got all the equipment that you require, the helmets and so on, for when you are in proximity to the crater. So again, this is from our meeting place. The guide Renzo had his dog Raxa along. You'll see Raxa later on. So the point here is that our climb, in contrast to the main tourist route up, is one in which it's a bit of a scramble at times. So there's a little bit of easy scrambling up the ridge, but essentially a steepish climb up the ridge where you can see the crater and the fire stream slope at all times. And that makes it very interesting. You also see signs of big paroxysmal explosive activity. And here's a typically pear-shaped lava bomb from obviously a very big explosion from that crater. You wouldn't want to be around when lava bombs of that size were landing on the ridge. And then up in the upper right, you can see higher up on the slope, the view across towards the steaming crater area. So the main point of starting that trip only about 4 p.m. is to arrive on the summit at about sunset, where one gets a good view as dusk approaches of the volcano. And by that time, of course, we got there quite early, fortunately ahead of most of the tourist parties. And so this is where you can see scores of tourists now settling down to look at the view. On the horizon, the southwestern horizon over there, you can see Salinas and the 2 other islands further off to the west, Alicudi and Filicudi. So this is what we were wanting to look down on. This is our view across the main crater area. In the upper right, you can see Vince and Roz settling down over there. Here's the dog Raxa, who came on here. And I might just point out these structures over here are part of the monitoring equipment up on the top there. One of those pieces of equipment is a webcam, which is aimed down at the craters so that they can be monitored visually at all times. And that will have some significance later. So that's what we were doing. We'd come up there just at dusk as the sun was setting to look at the activity as night fell. And here you can begin to see the glow of these two little eye-like craters in the summit region, the active summit region. What I'm now going to do is show a picture a video taken in 2018 by our guide Marco Fulle at one of his previous visits to the area. So if I just get this going, I won't show the whole thing. Just make sure that the sound is on. So this was taken in October 2018 by Marco when he was up with another party. And you can find it on the web if you're interested in looking at the whole thing yourself. So there are those two little glowing eyes that we saw in my previous photograph. But you'll see other kinds of activity. So that's the blast, the Strombolian blast of ash out of the, and lava bombs out of the crater. And then in the background, you will see something else. This is a very energetic, it's something that we call the Bunsen burner. So that, as I say, we call that the Bunsen burner. There's a rather spectacular eruption from the crater in a while. So this is what, from about 6 p.m. when it started to get dark, we watched until about 9 p.m. all of this kind of activity, the glowing craters in the foreground, and then the Strombolian blasts with occasionally these very furious and very energetic gas exhalations from the other vent in the closer towards the east. We have one more look at the let's see if we can get the Bunsen burner again. There we go. So I'm going to carry on now to the, so that was our evening on Stromboli, and it was a very spectacular evening indeed. That was just a short excerpt from Marco's video. The next day we embarked on the ferry heading back west towards Lipari. There's Stromboli giving a final little blast just as we were about to board the ferry in the upper right. So Lipari, our tour there was a rather brief one. It was just an afternoon. It started off with lunch at a very nice restaurant called Il Gaglione in the main town on Lipari. We drove anti-clockwise or counterclockwise around the island, stopping at a big pumice quarry, which is no longer active, some outcrops of volcanic glass or obsidian, and then just took a scenic view around the island then finally stopping on a view site towards Vulcano and Sicily, the mainland of Sicily in the south. So I'll go quickly through the slides. This is a picture taken of the pumice quarry, which, as I say, is no longer active. And so all of the industrial complex over here is now abandoned, essentially. The upper right-hand picture is a picture of the actual obsidian outcrop that we looked at, just a closer view of it. A view out driving along the north coast to the island of Salinas. I mentioned up at the top there that was the, if anyone has seen the movie Il Postino, which is a pretty good movie, it was set on the island, or part of it was set on the island of Salinas. And then this is the view southwards now. The bay containing the hotel that we stayed at in Vulcano, the dormant crater of Vulcano itself over there, and the rest of the island behind. And then the fort, these are actually a faulted cliff zone along the southwestern side of Lipari. Within the background, Mount Etna just on the horizon, with mainland Sicily in the background there. So from there, we boarded the ferry again, went back to Milazzo, and then essentially it was already dusk. We drove through to our site on the Massif of Etna. And we stayed at a hotel just west of the main cable car station at the base of the South Ridge. So there's you can't quite see it very well here, but there's a cable car route going up. The upper station is somewhere around here near Montagnola. And you'll see the route after that from the upper cable station is a road that goes up to the Philosopher's Tower, which is the guide base at the base of the main summits of Etna. Over on this side, you have the Valle del Bove, that's the Valley of the Cows, and this is the Sciara dell'Asino, which means the donkey's back. So whereas we have a lion's head in Cape Town, on Etna they have a donkey's back, which is the ridge below the southern summit of Montagnola. Again, on Etna, you're required to have an accredited guide with you. So this was Rosario, who met us at the parking lot of the cable station. And this is a view through a rather dirty glass on the cable car, looking back down towards the lower cable station as we were going up. You are met at the upper cable station by buses if you want to go further on up to the Philosopher's Tower and beyond. Yeah, they have these four-wheel drive buses which then take you up the road. You can see the road winding up. The Philosopher's Tower is up on the ridge between the main summit craters. This is the new southeast crater, and the what is called the crater Barbagallo, which is on the left of that photograph. So this is a view taken from the crater Barbagallo. And again, I just point out that little white spot over there is the fissure that was still steaming, which was at the head of the lava flows from the 2018 eruption. So the 2018 eruption was a big explosion from the new southeast crater, but also the eruption of lava from a fissure on its flank. This is looking down at the guide base. The upper right shows the guide base from the crater Barbagallo. And again, that's the fissure area on the slope of the new southeast crater. Now, unfortunately, my knees had been somewhat damaged by the night descent from Stromboli. So this is the highest I made it. Steve Richardson made it to the top, but I didn't. I hung around on the crater Barbagallo, and so you won't see any higher shots from me. but maybe Steve can give us a talk at some stage on the real summit area of Etna. So I mooned around or mooched around on my own on the Barbagallo, and the Barbagallo craters were formed in 2002, 2003, with a rather major flank eruption from Etna, which then flowed pretty close down towards the outer parts of Catania. That's Catania, Montagnola, and Catania in the background on the left-hand side there. This is looking up to the new southeast crater on the right-hand side. We explored the rest of the day after the summit party had come down and rejoined me. We hiked down from the Barbagallo, looking at the various fissures and lava channels that are exposed from the 2002, 2003 flows. And then, of course, we headed back down the cable station. So the final day on Etna was then the day in which Steve and the two guides went back up the cable car, over Montagnola and down into the Valley of Cars. But me and the two Australians, we took this path coming from our hotel down the road and then up a hiking path or donkey track really to the Donkey's Back. That's the ridge which goes up along the southern side of the Valley of the Cars up towards Montagnola, which is the summit close to where the upper cable station is. So again, just a couple of views. The craters near the lower cable station are called the Sylvestri craters. This is looking back from our path towards that area. So it's looking westwards, then looking eastwards out into the Ionian Sea is what we are doing now. And then the lava slopes in this area were created by a fairly major flank eruption in the late 18th century, the 1792 to 93 flows. And again, what you see in the upper right-hand corner over here is one of these lava tubes. So you can see it's been broken, the hollow lava tube with the sort of ropey lava exterior on the outside there. Here we are arriving on the Donkey's Back, the ridge that runs up to Montagnola, which is the peak on the left-hand side, and then the new southeast crater and its fissures up at the top there. And then the darker flows over here that you can see on the right-hand side are the 2018, the most recent flows from the big fissures. So there's generally, this flank of Etna is actually a fairly major fault zone, and there have been numerous earlier flows of lava from the fissures along that summit. So, so that's what you see as you look down into the Valle del Bove. This is just panning around now. Again, the 2018 flows are quite visible with the older, I think these are 1950s, and there's the 1992 flow also down into the Valle del Bove. This is a view out in a northeasterly direction. The town of Taormina is up in the haze there, and essentially a final view out in that northeasterly direction. So this is the whole side of Etna that we know from the GPS monitoring of the region is slowly, but very slowly sliding down into the Ionian Sea. And as I say, that's one of the big hazards, not only the volcanic hazard, it's the flank collapse, the tsunamis, and the earthquakes. So that essentially brings us to the end of that trip. We went back to the hotel. We then spent the next day moving back down to sorry about that. So we went back to Catania, but then this was an aftermath. So we were on Stromboli on May the 8th, 2019, at about 2 p.m. on the afternoon of July the 3rd, and very fortunately not on the evening of July the 3rd, and even more fortunately not on the evening of May the 8th, Stromboli went into what they call a paroxysm, a large eruption. And so I'll just show you some of a Guardian, let's make sure that the sound is on. But these are just some views that one can pick up off the internet of this July 2019 paroxysmal eruption of Stromboli. The important thing about this is that and I wasn't able to show it, I would have liked to have shown it, but the webcam that I was sitting next to and that I pointed out to you from my slides that were taken up there, there is a record of that. In fact, it's been posted by the INGV, and essentially it's the last 2 minutes in the life of that webcam, because that was all the warning that was had by, that would have been had any tourists been there. Essentially what one sees on that webcam is one sees the Bunsen burner go off very strenuously. And then within about 15, 20 seconds after that, one sees the two little glowing lava craters begin to overflow. And then about a minute later, the whole summit area exploded. So anyone at the summit of that time would have had less than 2 minutes warning about that. There would have been no chance of escape. And there was fortunately only one fatality on the afternoon of that, and it was an injury of a tourist who was actually fatally injured by falling because he was in such a panic running away. That's it. That's my final slide. This is the view, again, the satellite view of the 2018 eruption, but that's it. This is not Stromboli. This is actually a 2020 explosive eruption on Mount Etna. And even now, at the present time, Mount Etna is doing some quite interesting, very active Strombolian stuff. So that is it. Thank you very much for your attention.
Thanks, Chris. Thanks very much for a fascinating presentation.
I have a question, if I might.
Okay, sure.
Just looking at the structural side of the eastern side of Etna there, and with the swarm of faults that you have in that area, are there any comparisons to the St. Helens type structure and the Etna structure? And are there any sort of ideas that there could be a similar eruption on the eastern side of Etna?
Well, they are rather different. Etna is a basaltic magma, so it's whereas Mount St. Helens is more you're not likely to get the same explosive type of, or large scale explosive type of activity that one gets on Mount St. Helens. Mostly you get the paroxysms, which is really gas escape from the basalt lava. And then you get the big fissure eruptions, which send down these very fluid flows, like the one that overtook Catania back in 1669, and also the 2002-2003 eruption. So
okay. Those are the ones that basically then resulted in those flows down the side that you could see. I think you said 92 was it, those?
So,
can I ask a question, please? So I would like to know that as much of this activity can be predicted with relative accuracy, does the Italian government have serious evacuation plans in place in case one of these predictions actually comes true? Or do they regard it as so unlikely or so unpredictable that there's no point in having an actual plan?
Look, their monitoring is certainly fairly top class. The Volcanoes in documented with seismometers, various kind of gas measurements, geochemical stuff. And they publish a weekly bulletin, which I look at occasionally just to keep track of what's going on. So they, and in particular, if there's any anomalous inflation of the, because you can pick that up on GPS, if there's any anomalous inflation, then they go into some kind of alerts. But I'm not too familiar with the actual, call it disaster management plans. Certainly on Stromboli, they had evacuated people during previous eruptions, and during the July eruption, they were getting most of the women and children off the island to Lipari, with only, say, the family heads, the males staying behind. So yeah, so there are, I'm sure there are evacuation plans. In the case of Catania, well, it's a fairly large city, and so it's not quite as easy to evacuate over there as for Stromboli.
Thank you.
Jean Faure speaking. May I ask Chris to tell him about a comical incident? Do you hear me?
Yes, I can hear you. Yes, indeed.
Yeah. Mary and I, we were newly married, and we traveled in southern Italy, Taormina. We stayed at Taormina, and I was desperate to see Mount Etna. And we drove that day along the coast towards Mount Etna, and it's a very lots of tunnels and you know, a windy road all along the edge of the sea. And then we heard a siren going, and Mary said, "That's it, John. Mount Etna is erupting. You stop here." And newly married, an abiding husband, I actually stopped there, but I was absolutely furious. I mean, I stopped and I actually walked out of the car for some distance just to cool down. And I never saw Mount Etna, and we turned down, and to this day, never saw Mount Etna.
Oh dear. Yeah, it's quite a nice...
It turned out to be an ambulance going past.
Yeah, 2017, we did a drive from Taormina, and then there's quite a nice, there's a village called Zaffarana, and you go up to the cable station along a road go winding up there. It is quite a spectacular thing to do.
And Chris, just picking up on Steve. Steve, are you still there? I mean, you presumably can add some more color to this presentation. So in our series on volcanics, we look forward to getting your views on it as well. And maybe you can also touch on the terroir and the wines that are grown in that region as well.
We look forward to that.
Oh, sure.
We look forward to that.
Yeah.
And next week we've got Mike. I see Mike's sitting looking at me. Welcome, Mike. Our next geologist. Lovely to have these lectures, John. Well done. Absolutely super.
Pleasure.
Any more questions? Well, remember the same slot next week. It will be Mike.
Okay. I look forward to that. Yeah.
Yep. And that, for the moment, brings our geologists to an end, but we're picking up again in a few weeks' time. Thank you so much, and welcome to everybody who has joined us. Please, we look forward to having you do so again. And thank you, Henny, for your hosting. Thank you, John, and thank you very much, Chris. Fascinating. Thank you so much.
It was a pleasure. Thanks for inviting me.